Okay, so in this video, we're going to be looking at trigonometry, just an introduction, motivating the need for trigonometry, and just the basic, looking at the basic trig ratios and when we might use those trig ratios. In the next video, we'll be taking a look at some of the examples using trig, but in this one, we'll just be looking at a light introduction into trig. So far, it would have learned Pythagoras Theorem. So if I was to give you a triangle, not the best drawing, but if I gave you a triangle, this side had 3 and this side had 4, you'd be able to easily find this missing side by using Pythagoras Theorem. So this would just be 5. But what if we got a case where we have a right angle triangle again, but this time we only have one of the sides, but we have another piece of information, and this time it's not another side, but instead it's an angle. So if this was 30 degrees, so in this case we wouldn't be able to use Pythagoras anymore, but we would need to use trig, okay, or trigonometry. And using the 3 trig ratios, which we'll be looking at, would be able to easily find this missing side or this missing side here, the hypotenuse. Now, before we get into trig, we'll just have a look at the different parts of the triangle in relation to the angle that we're given. So usually, or when we first look at the examples, we'll be given one of the angles and one other side, and we'll have to find one of the 2 missing sides. Now, the angle, we'll call it theta. So usually when we have a given angle, we denote it by the Greek letter theta. Now we define the triangle with respect to this missing angle here, and we'll see what I mean by that. So this side over here, the side that's actually opposite this angle here, so you can see that this side over here, this side of the triangle is opposite this angle here, theta. So this side is actually what we refer to as the opposite side. Very intuitive. And this side here, the side that's not the hypotenuse, so the hypotenuse, remember, is always the side that's opposite the right angle. So actually I'll write that in hypotenuse. Ooh. Let me rub that out. Oh. So hypotenuse. So this side, the side that's opposite the right angle, is always the hypotenuse. And this side, the remaining side, which is kind of next to this angle here, is what we call the adjacent side. Okay, so this is how we look at the right angle triangle. And one thing I forgot to mention is that with the trig that we're learning in this video, we're going to be just looking at right angle triangles. We'll extend trig to any triangle, but for the time being, we'll look at right angle triangles. So just to reiterate, our side that's opposite the angle is just called the opposite side. The one that's next to it is the adjacent side, and the remaining side, which is opposite the right angle, is the hypotenuse. Okay, so now that we're familiar with how to describe a triangle, we'll look at the trig ratios. So there's actually 3 trig ratios. So one of them is sine, and the other one is cosine, the other one is tangent. Okay, now sine for short, usually you'd see it as just sine. Cosine you would usually just see as cos, and tangent you would see it as just tan. Now we use these ratios, so we call these trig ratios. We use them depending upon the information that we're given. So if we have the angle and one of these certain sides given, and we need to find one of the other sides, we'll have to use one of these specific trig ratios. So that'll make a bit more sense when we look at this acronym, very popular acronym. So I should have color coded these, but we'll do sine in red. So sine, the acronym, the mnemonic rather for sine is SO. For cos, it's car, and for tan, it's toa. Now you probably heard this before. This is a pretty popular little mnemonic here. But what this means is that we use sine, so this S stands for sine. We use sine when we have the opposite side, so that's what the O stands for, and when we have the hypotenuse. Hypotenuse. Oh, a bit messy there. And we use cos, so C stands for cos when we have the A, so adjacent side, and we have the hypotenuse. So that's what the H stands for, hypotenuse. Okay, now you can probably guess with the tan, so the T stands for, I should space these out a bit more, tan, the O stands for opposite, and the A stands for adjacent. So what do we make of this? Basically, if we have the opposite side, so for example, we might be given the opposite side and we want to find the hypotenuse and we're given the angle, well, we will just use sine. And if we were given the adjacent side and the hypotenuse, we would use cos, opposite. And if we're giving opposite side and the adjacent, we use tan. So this will become much clearer in the next example, how we can use these. It will become much clearer when we look at the examples in the next video. But before we finish the video, I'll draw up a triangle just to illustrate a bit more clearly when we might use the different ratios. So for example, I have this right angle triangle, and in here I have the angle 30 degrees, and I've been given this side here, so this is 3, and I want to find this missing side. So what I first need to do is actually identify which side, which pieces of information I've been given. So I've been given an angle 30, I've been given this side, which is actually the opposite side, so I know that I have the opposite side involved. Okay, and I've been given the hypotenuse, so the side that's opposite the angle, so the right angle, so this is the hypotenuse. So I have O and I have H, so which ratio should I use? So obviously I should use the sine ratio because it's got opposite and hypotenuse, which is what we need to use in order to determine this missing side here. Now let's have a look at another example. It's not always a case that the right angle has to be in that particular space, it's not the case that the given angle has to always be in this particular angle. I could have it in this one here, so 45 degrees there, and this time I'm given this side here, 3, and I want to find maybe this one here, this side here, x. So again, looking at the information that I've been given in relation to this angle, so this is 45 degrees here. Now this side is, we'll call this a right angle. So this side, the x, is the opposite side. Okay, it's always easiest to determine the opposite side. So as a little tip, I would suggest that you find the opposite side first. And the hypotenuse is also quite obvious. It's the one that's opposite the right angle. And then by the process of elimination, you can determine the other side to be the adjacent side. So this x is the opposite side, and this 3 is next to this 45, so that makes it the adjacent side. So we have adjacent and we have our opposite side involved. So what we will use is actually the tan ratio, okay, since it's opposite and adjacent. So in the next video, we'll be taking a look at as many examples as we can, and hopefully after we go through all those examples, this will make a lot more sense.